Yeah, I was saying today's lecture is going to be enjoyable and easy. As we transition to 1 to 100, you will see this very often. In fact, you might have seen this in the CI/CD class as well. Okay, this is CI/CD, like it's so simple. And ऐसा ही होता है. Most, as you move to system design, as you move to senior roles, the things that you are learning are harder conventionally. It feels very jarring. But once you understand them, they are so easy and they give you so much power. Ki, Achha, this was it. And you can, negotiate better salaries or, answer questions in senior engineer interviews, so on and so forth. And they're also more interesting. They are one step ahead of everything we've done. Today is one such class. Before we start the class, I will share, some where we are at, what we are doing, what we are going to do. I've written a few points. This is purely based on talking to a few people who are now being referred. And, I'm seeing some inconsistencies, some things that you should try to fix if you are going to, if your goal with the cohort was getting a job. Then number one, if you weren't able to afford much, you got 0 to 1. 0 to 1 people can stay till the end of the month, learn some SE stuff for the next 1 month. And 0 to 1 is almost complete. There are some very off-topic random things like OpenAPI spec that we need to cover, certbot. I'll add them as offline videos, but I think it's time to move on to, some solid senior engineer stuff. Start contributing to these repositories. You have enough knowledge. A lot of your peers are already doing it. And there are decent bunch of issues. There is like a lot of things to improve. One small thing I can point out is, since Soham has lectures now, or, we'll probably have DSA lectures. A very good thing to add might be if this is a DSA track and there is a problem, the problem statement comes right here. It's not very difficult to add. There are some parts that are difficult, but UI is easy, simple, backend is easy. There are harder stuff which we'll cover in 1 to 100, but simple things you can start to pick up. There are a lot of issues there. I would start contributing. Only then do you know, do you really understand it? Can you understand other people's code? So people who are in 0 to 1, try this out. There are a lot of people contributing. I'm not being able to keep up with PRs, but I will. I'll be spending a decent chunk of time here. Please focus on English for remote jobs. Unfortunately, the first filtering criteria is everyone wants to know, can they talk? Do they have decent communication skills? This was a great thing about Abhishek. This is a great thing about Harpreet as well. Sorry, I think it's Harpreet, right? Yeah. They're both pretty good in English. Even though they're good at Hindi, they're good in English as well. Speak slowly, get a mic, have a decent background, simple stuff if you're going for an interview. As an intern, I think this is decent, is to ask, Harkirat, you to talk about 4CR. Yeah, as an intern, even I did not make this much in college. This little bit more than this was my Goldman offer. So I think as a college intern, this is a decent task. As a fresher full-time, this is a decent task. If you have more experience, frankly, pick and choose, but I think this is a decent task. That's all I wanted to share before we start. We're very close to I'm officially concluding 0 to 1, but there will still be more classes that will be beginner friendly sort of, and a bunch of offline videos that will come throughout this month. 0 to 1 people can stay this month. With all of that context, let's get right into today's session. Today's session is on advanced backend communication. This is the first topic of 1 to 100, where we'll understand. We were able to understand HTTP until now. What else exists? How can backend systems talk to other backend systems? That is the context of today's class. The most important implementation we will do today will be of WebSockets, which is this thing you see right here. But there are many ways for backends to talk to other backends. We'll discuss a bunch of these ways today. We'll discuss the implementation of WebSocket today. Tomorrow, probably we'll go through either PubSub or messaging queues. That's the goal for this week. Okay, very jarring, but actually fairly simple backend we're able to cover. Let's get right into today's session. This is a brief graph of how backends communicate. But before that, you might ask, Harkirat, backends communicating? Why does one Node.js backend need to talk to another Next.js backend or Golang backend? Why does this need to hit this server? Usually communication happens between a client. There is a browser over here that hits a backend system. Why is one backend system talking to another backend system? And the answer is, as your application grows, you don't want to keep everything in a single server that is exposed over the internet. You are literally saying, this backend server, people can hit from their browsers, and I will put everything here, including sensitive things that, you probably don't want exposed here. Also, there is something called asynchronous processes. Harkirat, asynchronous, I understand a little bit. What is an asynchronous process? A very good example is a notification that you might get on your phone when you transfer via Google Pay. When you transfer someone 100 rupees via Google Pay, the actual transfer minus 100 on your bank plus 100 on their bank needs to happen on this layer most probably. Most probably, the primary backend needs to take care of it. But the notification, the email eventually going out to them, the push notification coming out, the SMS going out can happen in its own time. Even if it happens after 10 seconds, it's fine. The primary backend server that's handling the core of your business should probably not be worried about this. Another good example is analytics. If you have a lot of people coming to your website, your primary backend server, your Express server shouldn't be tracking, oh, a million requests are coming, let me put them in the database. It should be offloading all of this to someone else, even if the final response, comes after some time. Another good example of this is if you go to any exchange or backpack.exchange, for example, the trading bit, if I actually trade something, needs to happen instantly. But if you look at the rewards, which, let's say show you how much volume have you done, which, as it says here, $16,000 or whatever. This, even if it happens after one day, it is fine. This is not a necessary thing for the person to see right now. But trading needs to happen instantly. These are examples of core system backend handling the, requests of the user and core thing that they need instantly. And then a bunch of backend processes handling asynchronous requests. Okay, chalo, after a day, we will calculate how much money have they made. Another good example of this is if you go to Dukaan, if you've heard of Dukaan, Shopify, if you go to mydukaan.com and sell some t-shirt, you will see all of your orders. Where is Dukaan? I mean, I won't open the dashboard, but you get the idea. If I log in over here, I will see a dashboard like this. The total sales are usually, they come at end of day. At end of day, you see, acha, today you made 54,000 rupees sale. But every order you're seeing immediately. So this is an asynchronous process that will calculate how much money you made throughout the day. Everything else is a synchronous process. These asynchronous processes usually run on different servers, and your primary server needs to talk to them. It needs to tell them, okay, bhai, please after one day, calculate the total money this person has made today on Dukaan. What is Dukaan? It's a place, it's like Shopify, an e-commerce website where you can sell products to other people. And then you have a dashboard where you can track how much money they have, how much sales they have done, and their total sales of the day, so on and so forth. So this is how general backends are architected. You don't put everything in a single place. That's the worst idea ever. This is also called microservices. If you've heard of it, you have various small services talking to each other. You don't have one monolith. You don't have one very big server. That is why backends need to talk to each other. The question is, how do backends talk? Does this backend server send an HTTP request to other backend server? Let's take an example. Let's say you're on Dukaan and someone made a sale, as in some end user bought your product. A request will come here, okay, the product has been bought. You will update the database, okay, the product has been bought. Should you tell the aggregator service? What is the aggregator service? The service that is aggregating your sales for the day via an HTTP call. Okay, bhai, please add 200 rupees to their total sales of today. Or should you send it to a queue where you can, put a bunch of items in the queue? Okay, Harkirat sold one t-shirt for 200 rupees. Harkirat sold another t-shirt for 500 rupees, so on and so forth. And then another process picks it up in its own time. Okay, acha, 200 rupees I will pick, I will add to the database. 400 rupees I will pick, I will add to the database. Or should they communicate via something called WebSockets? We'll discuss what these are today. Or should they talk to each other via pub subsystems? Harkirat, what are pub subsystems? We'll discuss tomorrow most probably. But as the name suggests, they're called publisher subscriber systems. Your backend one can publish an event and that says someone has bought a t-shirt, and then this backend can pick up and send them an email. This backend can pick up, send them a text message. This backend can pick up and aggregate their sales, this number in the database. So there are, various ways for backends to talk to each other. We'll discuss one of them today. I hope it's clear. Okay, why do backends need to talk to each other? Cool. Given that context, let me share some examples of, when backend systems would talk to each other and when you would have such decoupled backend systems. Good example is for Paytm. When you say I want to transfer 100 rupees to someone, it will immediately talk to the database, immediately do a plus 100 minus 100. It might actually do this also via an asynchronous process. But chalo, let's assume this happens instantly. But it will push onto a queue, send them a notification, send them a SMS on their phone number, send them an email. Harkirat, why can't it do it over here? What if the email service is down? What if whoever you are using for phone number is down? Will you, make the plus 100 minus 100 in the database and keep waiting? Okay, bhai, phone number, okay, it hasn't happened yet, retry. Do you want your end user to wait? No, their thing is done. They wanted to swap balance. The balance has been swapped. Everything else can happen in its own time, which is why you push these onto queues. Harkirat, what are queues? Well, as the name suggests, it's a queue. But like, Harkirat, show me a real implementation of a queue. We will see this tomorrow, most probably. But like a good example here is, RabbitMQ, if you've heard of it, or Redis also has a concept of queues. I will push this onto a queue, and then the push notification service, if it is down, it's fine. It will still remain in the queue. Whenever it comes back up, it will start to pick up messages and send people push notifications. Harkirat, then the push notification might take a lot of time. It does. When you send someone money on Google Pay, when your Swiggy order is delivered, you don't instantly see a notification. You see it after 20 seconds, sometimes after 100 seconds. So these systems can be highly asynchronous. Another good example is LeetCode, which is something like we're trying to build on projects.100xdevs.com. People come here and are able to, submit coding problems. When someone comes to your platform and submits a coding problem, should you on this backend itself evaluate that? You shouldn't. Why, Harkirat? Because the C++ program that they are submitting might have an infinite for loop that will take up your core of this main backend system for running that while loop infinitely. So you definitely don't want to run other people's code directly over here. Harkirat, where should we run it then? You should run it on, some separate service, some separate server. You should not run it on the primary backend. So what can you do? You can take the user's submission and push it onto a queue. Most probably LeetCode and even us, when we build this, we'll have two queues. A premium user queue, where whoever has paid, their submissions will reach here. And then a free user queue. Someone has not paid, their submission will reach here. This is being handled by a small machine or, just a single machine or two machines. Premium user queues is being handled by a bunch of big machines. There shouldn't be any record here for more than 3 seconds because these people have paid. They need to have a good experience. So this is another use case where, your backend would delegate a task to other backends. And then eventually, whenever the submission is complete, this big machine can tell the database, accepted, rejected, TLE. And then, the end user can just poll the backend and get their status. That's exactly how LeetCode does it. We'll see this very soon. But that's a brief of backend systems talking to each other, how you build bigger backends as you have complex applications. Harkirat, what is a complex application? Great example of a complex application is LeetCode, where this is the complex part. In Swiggy, delivery tracking is a concept part. The driver keeps moving again and again. That system needs to, track them and notify the user that they are close enough. In case of Paytm, as I said, notifications it's not the difficult part, but it's the part that needs to be delegated. In case of an exchange, as I said, the order filling needs to happen immediately. When you go here and buy, or if you go here and sell, then the buy or sell needs to happen immediately. But reward point calculation or, notifying the user your order was filled can happen in its own time. Another good example is if I withdraw my crypto. If I say I want to withdraw, whatever, I have 36 USDC. I want to withdraw 30 USDC. Click on continue. This will also happen in its own time because this is dependent on the blockchain. Whenever something is dependent on another service, for example, you never buy phone numbers to SMS other people. You usually depend on another service. Twilio is a good example for this. If you've heard of Twilio, Twilio lets you send SMSs to other people. Similarly, SendGrid is an example of a company that lets you send emails. These are highly unreliable APIs. Phone numbers, can go up and down, SMS might not be received. Whenever you're dependent on something like this, you maintain a queue. Why, Harkirat? Because whenever this service pulls the message, if it fails, it can just push it back to the queue and then retry after some time. That is why a queue makes a lot of sense for systems where you're dependent on an external service. What is a good example? Blockchain is a good example if you're ever doing withdrawals on an exchange. Or, this is also a good example. Sending SMS, sending emails, so on and so forth. That is a decent context. I'm hoping this is straightforward. Let's do a quick poll, but then let's proceed to the next section. Are we good to go, guys? Yes or no? All right. So next up, let's understand the types of communication. This is common interview question. Whenever you're in a SE interview, they will ask you, in your last company, was there backend communications? How many did you have microservices or did you have monoliths? You will say, sir, we had microservices. That's a more, authentic answer to give. Then they will ask you, how did your systems communicate? Synchronously or asynchronously? Now this is jargon. I did not know I knew what HTTP means. I knew what WebSocket means. I knew messaging queues, pub subs, everything I knew when this was asked to me in an interview. I did not know what is synchronous communication, what is asynchronous communication. But if you think about it, it's pretty obvious. If one system is talking to another system directly, as in either via HTTP, ignore this, you don't know WebSockets right now, so feel free to ignore this. This is also debatable if it's synchronous or asynchronous, but HTTP is a good example of, okay, bhai, one system is directly pinging the other system. This is one system, this is another system. It's directly telling the other system, okay, bro, please send message via, let's say, an HTTP call. This is a synchronous call. Okay, bhai, abhi ke abhi karke bata. Do it right now and give me a response. I will wait for your response. When you are waiting for a response from another service, what is that? That is synchronous. What is asynchronous by the same, argument? When you don't wait, when you just push it to a queue and you're like, someone else will handle. As long as it was pushed to the queue, you are good. You don't have to wait for acknowledgement from the other service. Ki haan, I picked it up. You push it to a queue, you move on, you do your own thing. What is a good example? Messaging queues. When this backend is putting something in a messaging queue, it is putting it there. And it's like, okay, someone else will pick this up and send the final email. My job is done. That is what asynchronous communication is. Messaging queues is a good example. Pub subsystems are a good example. Server side events, debatable, but haan, theek hai, chalo, I did put it here. And WebSockets, as I said, is debatable. Why is WebSockets debatable, Harkirat? If you know WebSockets, I'll share quickly why it's debatable. Because when you have a WebSocket connection, you send the other side data, you don't wait back for acknowledgement. That doesn't happen in HTTP. When you send some HTTP data, you wait for a response. When you send a WebSocket data over a WebSocket wire, you don't really wait back for response, which is why it's very debatable whether it's synchronous or asynchronous. I would say it's synchronous because you are immediately sending the other service, okay, bhai, do this. Versus in these asynchronous systems, you are publishing to something, a messaging queue, a pub sub, and then the other services can pick them in their own time. You're not telling the other service directly, okay, bhai, please do this. So that's a brief about an interview question. How did your backend systems talk in your last company whenever you're giving an interview? Sir, they talked asynchronously. We had messaging queues between our main primary server and our email server. The primary server would push things onto a messaging queue. The email server would pull it from it and, send it out to the end users. It's a brief of the types of communication. This is just sort of an interview question I had, so I thought I'll share. WebSockets is the next one. Harkirat, why are we learning WebSockets? Is this also used for backend systems to talk to each other? Not really. WebSockets is rarely used for backend systems to talk to each other. It is usually used for a browser to talk to a server. Harkirat, browsers to talk to a server via HTTP. We have done this so many times. You create an Express server. Why are you introducing a new protocol called WebSockets for browsers to talk to a server? Good question. The answer is WebSockets provide you something extra. There is actually a small inefficiency in HTTP, not inefficiency. It's just something that's missing that WebSockets provide you. Okay, Harkirat, what is that inefficiency? Before that, let's understand what are WebSockets. The official definition. WebSockets provide a way to establish a persistent, full duplex communication channel over a single TCP connection between a client, typically a web browser, can be a backend system as well, but typically a web browser, and the server. Something like this. It creates a persistent connection. Harkirat, how is it different from HTTP? In HTTP, you don't create a persistent connection. If this is your browser and this is your server, you send a request to the server, you wait for the response. As soon as you get the response, you close the connection. It is not persistent. Send, get back response, good to go. What are WebSockets? WebSockets say, a lot of communication needs to happen between the client and the server. Let's create one single connection. The client or the browser can send events to the server. The server can send events to the browser. Hence the word full duplex communication. What does full duplex communication mean? It means duplex, both the sides. Browser can send events to the server. Server can also send events to the client. Can you ever do that in HTTP? You can never do that in HTTP. HTTP means server can't send events to a browser. You cannot go to the server and be like, fetch http://user_domain.com/something. The server can't ever find the browser. The browser can find the server by hitting a certain endpoint, and the server can respond back. The server can never push events on its own. WebSocket server can do that. That is why you might want to use a WebSocket server for use cases like these. I've given this sort of definition. What is a use case, a practical use case of WebSockets? When do you want server to push events to the client without the client even asking for it? If the client needs something, it can just ask for it again and again, right? Why does the server need to push? Usually a good example here is again exchanges or 10 different applications, but Exchange is a good example because you'll see a lot of activity here. Can you see these numbers going up and down? Can you see these trades? So many trades are happening. People are buying, people are selling. If you use HTTP to get, what sale has happened, can you give me the next order? What is happening here? Some event is happening. Every time you see an order here, someone is going and, buying some Solana. Someone clicked on buy over here. You see that order over here. All of these coming back. If you do this via HTTP, you will send 1,000 requests to the server and then every second, and then it'll respond back. Every time you send a request, you do what's called a handshake. I don't know how many of you have gone through computer network classes, but whenever you're sending an HTTP request, whenever you're doing a fetch, for example, to api.backpack.exchange/get order, something like that. Whenever you're sending this fetch request, you are sort of doing a very big overhead of sending some headers and then getting back an acknowledgement and then again sending back another acknowledgement, a three-way handshake, and then you actually send the data. So there is a lot of overhead you have to send with every request. If you have to send 1,000 requests a second, then you have to send this 1,000 times. Not good. Which is why you want to use WebSocket servers. The handshake happens only once. Handshake happens once, and then everything after that is you send data, you send data, you send data, you send data. And in this case, the data is, the orders that have been placed. Harkirat, can we see this in action? Yes. If you right click on inspect and click on the network tab over here and refresh, you will see a WebSocket connection, which is very hard for me to find because my search bar went away. This happens every time, but let me search for it. There you go. ws.backpack.exchange. If I click on this, very similar to an HTTP request, I see a WebSocket connection. And if I click on messages, I see a bunch of messages the server is sending me. If you look at the body of these messages, you will see it is sending you back, okay, the depth change over here, the depth change over here. Okay, what is depth? Don't worry about it. But any real time events that you're seeing, all the trades that are happening, this order book being updated is coming via a WebSocket connection. This is a primary use case of where you want to use a WebSocket connection. Why, Harkirat? Why can I not keep sending, okay, give me the current order book, give me the current order book? Overhead. You'll be sending 20, 30 requests a second. Just create a single connection. Tell the server, okay, bhai, please keep sending me messages. And then the server will just keep sending you the current state of the order book, the current recent trades that are happening, so on and so forth. That is what WebSocket sort of connections let you do. Use cases for WebSockets, real-time applications. What is a real-time application? A chat application is a good example. Even, this, everything you see over here is a good example. All these events are happening in real time. You don't want to refresh the page. You want these come to you quickly. That is why. That is one thing, place where you want to use WebSockets. Live feeds. This actually is a better place to put, a crypto exchange. Financial tickers. The graph going up and down. Even if you open Binance, you will see, a very similar order book over here that is getting updated. This price graph will go up and down. This price will keep changing as orders get matched. As you can see, it became something else, then something else. This is a real-time application. A ticker being, the current price, is a good example of where you want to use real-time communication. Interactive services, Google Docs or, whatever, Replit with two people typing at the same place is also a place where you want to use WebSockets. Why not use HTTP? As I said, you will keep sending requests again and again and again. And you don't want that. You don't want to send. There's a lot of overhead that comes with every request. What is overhead, Harkirat? You're sending a lot of extra data along with, please give me SOL price. You are doing a three-way network handshake, which is, very computer networks concept. But if you've read through it, you're sending a request. The server is responding back, I got you. And then you respond back with, I also got your acknowledgement. You do a three-way handshake and you are doing it again and again for every HTTP request. And you can still do this. Companies still do this. This is, even though it's an ugly approach, companies still do this. In fact, LeetCode does this. When you go to leetcode.com and try to, create a submission, let me quickly do that. Oh my God, my eyes. White mode. Okay, there you go. Dark mode. If I do a submission over here, if I go to some problem, open the network tab, click on network. When you click on submit, as I said, the application might take 1 second, 10 seconds, doesn't matter. Eventually it will do your submission and it needs to push an event. It needs to tell you, okay, your submission succeeded or failed. So WebSockets is a good use case here because the server needs to push an event. Whenever you're submitting to LeetCode, if this is LeetCode server, you tell them I have created a problem or, submission. It will tell some random, it will push this onto a queue. Some other service will pick this from a queue and then actually do the submission. And then whenever the submission is succeeded, it will put this in the database. Ki haan bhai, successful or failure. Ideally, when this event happens, it should also tell a WebSocket server that the submission failed or succeeded. And then this backend WebSocket server should respond back to you. Okay, you got a wrong answer. That's how I would expect to build this system. But how does LeetCode do it? LeetCode uses something called polling. What they do is, okay, bhai, you submit the problem. It is still doing a very asynchronous operation. Request going to a queue, getting picked from a queue, getting solved, and then the final submission being stored in the database. But the user doesn't connect to the LeetCode server via a WebSocket connection. I repeat, the user doesn't connect to the LeetCode server via WebSocket connection. It just keeps asking every 1 second, is my submission done? Did I get a TLE? Did I get a wrong answer? It keeps sending that request again and again. It keeps polling the LeetCode server. Did it happen? Did it happen? This is another way to do real-time communication. You can always poll a server. Okay, bhai, did my thing happen? You wanted to send me something. Can you please send me? Rather than the server sending you something, you can just keep asking again and again. Do you have my data? Do you have my data? Do you have my data? And that is how LeetCode does it. If you click on run over here, you will see a bunch of /check requests are going out. The first request does the submission. This one, most probably interpret solution. We look at the payload. I am sending my code over here, and then a request goes out to /check that responds with status pending. Another request goes out to /check status pending. Another request goes out. I am polling. Do you have my submission? Do you have my submission? And then eventually, when this whole process succeeds and the database has your final solution, when you ask for the data, you get back, okay, your submission was accepted, rejected, whatever, run code error. So yeah, long polling is another way to do real-time stuff. Should you do it? Probably not. Depends. In this case, works. Does it work in case of, a place where so much data is incoming so fast? No. For an exchange, does not matter, does not work. For a lead code like solution, might just work. In fact, it does work. They're such a big company, they still do this. Cool. That's what are WebSockets. Next up is just a bunch of implementation. How do you create a WebSocket server? How do you scale a WebSocket server? So writing a bunch of code, fairly straightforward code. Let me do a quick poll. Are we good to go, guys? All right. So WebSockets in Node.js. Let's understand how can you create a server, a WebSocket server. How can you send data from a server to a client to a server? There are many implementations of WebSocket in Node.js. Just like you can create, if you want to create an HTTP server in Node.js, you can use Express, or if you remember, you can use, I don't know if I introduced Koa, but that's another HTTP framework, or you can use Hono. These are all implementations of the HTTP protocol. These are all implementations of the HTTP protocol. These are code that a bunch of people have written, and then you just use their code and create your HTTP server. You don't worry about how the HTTP protocol actually works. These developers have worried about that. You just use their code. Similarly, WebSockets is also a standard. You can read about how should a WebSocket server be on, IETF, this RFC. And it will tell you the WebSocket protocol does this. And then, you can read about how a WebSocket server should be built. When you're in a trading company, if you ever join Jane Street, if you know what's his name called? The YouTuber called Joma Tech. He used to work at, some trading company. He built, his task was go to this, read about the protocol and implement it from scratch in C. A lot of times, companies that really care about latency of systems talking to each other will build a WebSocket server from scratch in, some low-level language. But does it matter for us? No. We will highly depend on, someone else who has written all of this code in JavaScript, C++, doesn't matter. Just because you're using a library like this that says, that's on NPM, doesn't mean it's written in JavaScript. It actually can be written in C++ as well and have an API on top that's in JavaScript. So I don't know how this WebSocket client is written, but it could have just been written in C or C++. Either way, these are three popular implementations. The first two are pure WebSocket implementations. The third one, called socket.io, is something you might have heard of, might have seen. This is the first beginner-friendly way to, do full duplex communication for backends to talk to frontends and frontends to talk to backends in a persistent way. You probably don't want to use socket.io. There are a few problems with it. The biggest one being even though it's written on top of WebSockets and you can sort of convert a socket.io server into a WebSocket server, it's harder to support multiple platforms. If you create a socket.io server, your website will be able to talk to it. But if you're creating an exchange, you also have to create an app. What if you create an app that's in Android? Then you need a socket.io implementation in Android. There is one that exists. But what if you want to create, a Rust server that needs to talk to your socket.io server? Then you need socket.io implementation in Rust. And all of these exist. Like there is a socket.io Android client, there is a socket.io Rust client. But these are not maintained as much. WebSockets is a very global protocol. So WebSocket clients generally exist very frequently. There is an Android WebSocket connection. Websites to support WebSockets by default. So in the browser fetch, just like there is a browser fetch API, if I right click Click on inspect. Just how fetch just exists as an API to send a backend request, WebSocket also exists as a construct on the client that you can just use. So browsers to support them from scratch. Rust also has a WebSocket client implementation. So even though you can use Socket.io, probably shouldn't. A lot of companies started here because it's very easy to use it. It gives you some constructs like rooms that let you do, very simple, that let you send data to clients very easily, but you should avoid it and just stick with the core WebSocket protocol. Now let's get to some coding. Fairly straightforward code. If you've written an Express server, this should be very easy to write. Let's write WebSockets in Node.js, but the protocol remains very similar. You can write a Node.js server, a WebSocket server in Rust, in Golang, doesn't matter. Everywhere it's, the protocol core remains the same. Okay, there is a persistent connection between a client and a server. If you want to, feel free to follow along. I'm going to write this code, even though it's fairly straightforward code. But yeah, let's write it from scratch. The first thing you have to do is create an empty folder in your laptop. So let me do that. Let's call it week 19 WebSockets. And then let's initialize an empty Node.js repository here, npm init -y to create an empty package.json. I repeat, create the folder, go into the folder, and then do a npm init -y to initialize a package.json. Then initialize a tsconfig.json by running npx tsc --init. Now open it in Visual Studio Code. All the steps are here. I'm assuming it's pretty straightforward by now, so not going to wait a lot, but I'll still do a poll. Week -19. All right. I have the project open here in Visual Studio Code. If you look at the files, simple package.json, simple tsconfig.json, create a new folder, call it source, create a new file, call it index.ts. I will take a pause here and do a poll. Feel free to take your time if you are lagging behind. I know a lot of people like to code as well. Can I proceed, guys? Can I proceed, yes or no? And select no if you want to wait for 5 minutes. Can I proceed? No. Okay, that is fine. I will wait. No rush. Let's take a small mini 5-minute break. Let me answer a few questions in Q&A until then. All the steps are here. Try to create a WebSocket server by your own. Can't we use HTTP pipelining for making HTTP persistent? First time I'm hearing this, HTTP pipelining. And the small answer is probably no. Multiple HTTP requests to send. Oh, okay, I have heard of this. It lets you send multiple HTTP requests with a video conference. Does it let the server respond back without you sending a client request? Maybe it does. There are a lot of sort of ways for a front end to talk to a backend and exchange data. Two more protocols that happy to talk about here are Quick QUIC and WebRTC. If you use both of them, then also a client can talk to another client or another server persistently. There are various ways for you to do two-way communication between two clients. But yeah, WebSocket is the most popular one for real-time communication. Won't the server get overloaded with so many multiple connections? It will. So more horizontal scaling in case of WebSocket architectures. That is correct. We will get to that in the last slide. Is that why LeetCode is ditching for cost savings? I think it's just complex to maintain a WebSocket. Why do you want to create a fresh server and then make your user do two connections, one an HTTP connection every time and then another LeetCode server? I think just to keep things easy, they're doing long pull. I don't think money saving is something in their head. Redis is not open source. Going to ignore the. Will you cover Rust as well in Web3 cohort? Something I'm thinking. It will be very long if I do, but we won't be able to do Solana contracts very well if we don't know Rust. We'll see. What is polling? Long versus short polling. polling is what LeetCode is doing. Every second, bro, do you have something? No, I don't. Bro, do you have something? I don't. I have something? I don't. Long polling is, okay, bro, whenever you have something, respond back. Take your time. I know you have something. Your submission will eventually succeed. Whenever you get the response, maybe it's in 10 seconds, respond back to me. That is long polling. Okay, bhai, I'll wait. Keep my connection open. When you have the response, send it back to me. What is polling? Okay, bhai, do you have the response? Yes or no? No, I don't. Do you have the response? Yes or no? No, I don't. That is polling. What is long polling? Bro, whenever you have the response, send it back via this HTTP layer. Reshare screen. Okay, we'll just take a proper break only then. And 7 more minutes. We'll start at 7:50. Ishan Sharma, just ping Roki. We need TAs for Web3 cohort. It'll be a lot of questions because not a lot of content on it. Please explain why not to use Socket.io. Yes. The reason I said was, okay, if you created a Socket.io server, very good. You created a website, very easily you can, connect from this website to Socket.io. But now you have an Android app. Now you have to include a new dependency in your code base called, io.socket.io, Socket.io client 2.0.0. Every platform, thankfully, so Socket.io has good support. It's not like it will not work in, a Java program or a Rust program. They have created clients, but it's not the core protocol that IETF created. IETF created WebSocket. Every language has a WebSocket support. Android, you can simply, you probably have to have a dependency here, but website, you simply have WebSocket as a construct. Even in Android, a lot of support for WebSocket clients. What is a client? Something that can connect to a WebSocket server. Socket.io, all clients are community made. Okay, bhai, acha Socket.io came, so we will have to create a client in Rust, in Go, so on and so forth. So in C. So for that reason, you will have a lot of dependencies. That's the only reason. Do it in Next.js. We will eventually, like today. Polling causes a lot of database calls. It does. You are polling it. Not a lot. Like you can handle this scale. How many people are coming to LeetCode at a certain point? 20,000. How much are they polling? Once every 2 seconds. Your database can handle 5,000 requests a second. What if adding to the queue and queue is down, does not accept it? Exactly. That is a beautiful question. The question is, okay, Harkirat. In fact, if you go to this video of mine, Harkirat Singh roadmap, full stack, somewhere I say if your queue is down, you're screwed. This one. Go through this video. Pretty much covers what we're covering today. Complete full stack roadmap. इसमें बीच में I abuse a little bit when I say if your queue is down, you're screwed. क्योंकि if this is your server and your end user is like, okay bro, I want to send my friend 200 rupees, and the queue where you are storing all the events is itself down, then what will you do? You can do a few things. Either you can revert the transaction. कि नहीं यार, sorry, you will not get 200 rupees. Our notification system is down. Probably shouldn't do it. If a notification gets missed, it's fine. What you can do is, send data to another backup storage for now. Whenever the queue is down, send the data to a backup storage. And then whenever the queue comes back up, seed the data from the backup storage. Harkirat, what if the backup is down? Yes. What if the server is down? Of course. If things are down, your people will see downtime. The question is, what do you consider as, an important event? If you consider push notifications as an important event, then even if the database call succeeds, you will revert the database call and tell the user, sorry, our systems are down right now. Please don't, we won't accept your request. What if backend 1 goes down? Then your website is down. If backend 1 goes down, then your end users cannot communicate to your system. On Paytm, if you send someone money, it will say request failed. It will show you an alert. Your primary backend is down, your primary backend is down. Doesn't happen very often. When it happens, your systems are down. You can't do anything. If your auxiliary services are down, then you're still fine. If your auxiliary services, this is down, it's still fine. Okay, main backend server is up, database calls are happening. If it is a Paytm application, the person's balances are being updated. They are not getting notified. It's fine. But the primary thing is happening. But if this itself is down, you can't send other people money. As simple as that. All right, I think we have 2 more minutes. Backpack WebSocket layer is simple Rust WebSockets, nothing new. Where do you implement queue in the backend itself or on the server? It is, a queue is just a server that is running RabbitMQ. There is a server, like let's say whatever, an EC2 server that is running either RabbitMQ or running Redis, whatever is your queue implementation. It's just another machine. It's nothing special. It's a machine that is running a protocol or, a project that supports queues, that lets people push to a queue, that lets people pop from a queue. Having error while doing npx tsc -- init. Just copy a random ts config from a project here. Go to 100x devs code to open a random project, copy over the ts config from there. It just creates a ts config, so nothing new. Golang is not in Web3. We would have done Golang if we were doing Cosmos. We're not doing Cosmos most probably. So 1 more minute, guys, then we'll start. Since Cloudflare workers don't use Node.js as the runtime, then how do you use WebSockets there? I'm sure there's a WebSocket implementation there. Oh, are you asking about WebSocket clients? Are you talking about WebSocket servers? You cannot create Cloudflare workers, expose HTTP endpoints. They don't let you do serverless WebSockets. In fact, serverless WebSockets are very hard. So if this is the, your Cloudflare fleet, it only exposes things via an HTTP layer. If your question is, Kirat, can this thing, Cloudflare worker, create a persistent connection to another WebSocket server that's a normal WebSocket server? Probably can. Even though it's not in, I'm sure the Cloudflare runtime, supports WebSocket clients, but this is serverless. You probably never want a serverless server to have a WebSocket connection. What is the point of a persistent connection? This goes up and down very quickly. So yeah, serverless is a big no-no for WebSockets. All right, guys, 7:50. Let's proceed. We will be understanding a WebSocket implementation in Node.js, just writing some code. You can literally copy this code and ask ChatGPT, can you give me the same code in Rust? It will. Can you give me same code in Golang? It will. So, the code pretty much remains the same. The main goal is the idea. How do you create real-time connections? How do you scale real-time connections? Does not matter what stack your WebSocket connection is written in. Let's kick things off by writing it in Node.js. Hopefully by now, few of you have followed these steps. Let me quickly follow them as well. I'll do a poll after I finish as well. I created a tsconfig.json. I'm going to change the root dir to be ./src. I repeat, the root dir to be source so that all my source code is picked up from there. Out dir to be ./dist. Okay, the final output should be here. Then I will add the WS library as a dependency. As I said, there are various libraries, just like there is Express, there is Koa, there is Cow, whatever is called, Hono. Similarly, there are various WebSocket implementations. We are using this one in the middle right here. So I will add that as a dependency. And then here is some code. We can rewrite it, we can copy it and go through it. It doesn't matter either way. This is like less than 8-10 lines of code. One thing that you should know about creating WebSocket connections. Whenever you're creating a WebSocket server, you are actually creating an HTTP server only. If you go through the protocol, the WebSocket protocol, how is it built? The first connection that the browser makes, the first request that the browser sends is actually an HTTP request only. It gets upgraded to a WebSocket connection on the server, but the first request that goes out is an HTTP request, which is why whenever you are creating a WebSocket server, there is actually an HTTP, server running under the hood. It is still exposed on a certain, port, which in this case is 8080. So you are actually creating an HTTP server. Only the server, whenever it gets a WebSocket request, it upgrades the request to be a WebSocket full duplex connection. So I have two implementations of a WebSocket server, one using the HTTP library which is a library we haven't ever used. This is the native HTTP library in Node.js. And then there is Express, which we have used many times. So feel free to choose which code you would like to write. In the end, there will be an HTTP server that will be handling your requests. So the very first thing I do here is create an HTTP server by calling http.createServer and saying anytime a request comes, just send them back hi there if it is an HTTP request. Very similar to me putting, a app.get/* send the user some response. If you don't understand this, just go through the Express code. This is how you would write HTTP servers natively in Node.js. What does natively mean? It means without depending on any external library. Harkirat, you're saying we don't need Express. Yes, you don't really need Express. HTTP is good enough. Then why do we use Express, Harkirat? Express gives you very clean routing. It gives you an easy way to create middlewares. It has a very nice ecosystem of middlewares that you can use. That is why you use Express, but you can still create an HTTP server natively in Node.js. You never have to do what does natively mean? It means you don't have to do npm install HTTP. This comes bundled in Node.js itself. Create the server, and then we will use the WebSocket library, the WS library over here. Const WSS equal to new WebSocket server, and give it the HTTP server as an argument. You can also do this without HTTP servers. You can do no server : true. It will still create an HTTP server. Like you still need an HTTP server, but a lot of times you want multiple WebSocket connections. You want whenever a user connects to ws : / api.binance.com/ws/ one thing, they go to one WebSocket server, and then if they connect to whatever, I don't know, ws / user data, they connect to another WebSocket server. So you can read through, the code of WS library. They have a bunch of examples on their website. Let me quickly show you. They let you do very fine-grained configurations of, creating a WebSocket server. As you can see, it lets you do something related to performance. How much should you allow the user to sending and receiving data example, sending binary data over the wire, so on and so forth. Like they have a bunch of examples. We are choosing a very simple example. Okay, client can send some data, server can respond back with some data. So create an HTTP server, create a WebSocket server instance, new WebSocket server, and then this might seem a little jarring. So let's come to this later. But lastly, server.listen. You can remove all the WebSocket logic, comment all the WebSocket logic. This will just be a simple HTTP server that's handling requests. When you add the WebSocket logic is when it becomes a WebSocket server. This logic will remain the same irrespective of if you are using Express or HTTP. This logic changes. Okay, what HTTP server are you using, which right now is the native HTTP server. Now let's come to the most sort of jarring part of this specific library, because it uses callbacks. I hope you are comfortable in callbacks by now. If not, let's try to go through this code. It says WebSocket server .on connection, which means pretty reasonable, right? What it says. Anytime there is a connection, anytime someone, if this is a client over here, and then this is a server, anytime someone initiates a connection, control should reach over here. Control will reach this specific function, and you will get access to something called, you can call it whatever you want, but a WebSocket instance, a socket instance. And on this socket instance, you can be like, anytime there is a message, ws.on, not wss.on, ws, or to make it even cleaner, let's call this socket.on error. Anytime there's an error, just log the error. If this feels jarring, this is similar to the error, and then console.log error. And anytime there is a message, then to every client that is connected, there might be multiple clients, there might be this guy, There might be a second guy, so on and so forth. To every client that is currently connected on the WebSocket server, WSS dot clients dot for each, for every client, if the socket connection is open to them, because a lot of times it takes time for the socket connection to close, to open. A lot of time they might drop off. So this will, throw an error. So you should make sure that the connection is actually open and then send them the data. If the incoming data was binary, send them binary data. If the incoming data was ASCII or, simple UTF-8 or text, send them the text. This feels jarring, remove is binary as well. We will anyways not use any, binary data today. So this might feel a little weird. Here, too many things have happened. Also, this should be socket. These two are just registering a few events. This one is, if error happens, do this. If a message comes, do this. This is, okay, bhai, as soon as the user connects, send them a hello. Tell them, hello, you have connected to the server. Send them a message. So this is a simple send. These two are event registers. We have registered. Whenever there is an error on this socket, log the error. Whenever there is an incoming message, for every client that is currently connected, send them the same data that was sent by the end user. Very similar to a chat application, right? If you are in a chat application, if one user sends you a message, you broadcast it to everyone. You send them, this person said hi, you send them hi, send them hi, send them hi. In a multiplayer game, if I shoot you or if I move one step ahead, for example, if you're, this is like another company I used to work at that was a real-time game, very similar to a real-time game, something like this, where people can come talk to each other, move around. If I move, everyone in the room needs to know I have moved to, X, Y, which is why I send a message here. It gets broadcasted to everyone. Probably does not need to come back to me, but even if it does, it's fine. It needs to be broadcasted to everyone. That is exactly what our server is doing. Whenever there is a message, broadcast it to every client, because this is the most common use case. You might have some logic here. Okay, if client.room equal to Harkirat room, only then forward them the message or something like that. But let's say everyone is part of the same room in a game like this. Everyone is part of the same room. If I move a bit, everyone's machine needs to see that Harkirat has moved to X, Y. And we can ignore this part. I think that was a decent explanation, but if not, we will do a poll. Let's quickly run it and see it in action. Let's see, okay, whenever you create a connection, do I get back a message from the server? And whenever you send a message, does it broadcast the message to everyone that is currently connected? Let's see. How do you create a connection to this server? I have written some server code. I have written this thing over here. How can I write the client code? How can I make this client connect to this server? First, let's run the server. TSC-B to run the server. Compile the TypeScript code into JavaScript code. Node dist/index.js to run the server. This will start your HTTP server on port 8080 or whatever, WebSocket server, whatever you want to call it. Given that this server is running, how can I connect to it? You need clients, either a browser or something like Postman. Maybe Postman if it lets you send HTTP requests, maybe it lets you send WebSocket connections as well, or a mobile app. All of these can be various clients to an HTTP server. Let's use something called Postwoman, which was an open source project someone created a few years ago when I was in college. Eventually got acquired, renamed, I don't know. But it's called hopscotch.io today. So if you go to hopscotch.io, it looks very similar to Postman. It lets you send HTTP requests. It also has a real-time layer. I think someone told me Postman also supports this now. I could be wrong, but this too definitely supports this. I've used it many times. So what you can do is go to hopscotch.io. Let me just paste this in chat. And go to the real-time section. What is the real-time section? Okay, यहाँ से you can send HTTP requests. From here, you can create WebSocket connections. So let me try to create a WebSocket connection to localhost colon 8080. The way to do that is click on connect. Let me inspect, go to the network tab, and let's try to click on connect, see what happens. I'll wait for 15 seconds. What have I done? I've followed all the steps here to create an HTTP server. Then I have run the HTTP server locally by first compiling the code and then running the code. It is running on port 8080. If I go to localhost colon 8080, I do see hi there. So if I send an HTTP request, then this server does respond back with hi there. If I create a WebSocket connection, let's see what happens. Again, if I go to hopscotch.io and then this is my connection URL. Let me expand the network URL, click on connect. It says connected over here. And as you can see, there is a WebSocket connection in the network logs, very similar to the one I showed you on the Backpack Exchange or on Binance. Everywhere, whenever you create a WebSocket connection, you can track it in the developer tools. Thankfully, Chrome supports this now. And if you go to messages, you will see hello message from the server. Where does this come from? The server sent me a message. It comes from this line right here. What was this line? It said whenever a connection is created, send back to the user hello message from the server. If I put a log here, user connected, and then maybe maintain a user count, let user count equal to 0, connected, user count plus user count. I can see as users connect, and I can log that in my terminal. If I restart it and try to connect one more time, now I see user connected 1. Let me open another tab and connect from here. Now I see user connected 2. Let me send a message from here. Hello from client 2. Send. I get back some object. There's a bug somewhere. We can fix it very soon. But I do get back a message from the server. I also get back a message in my other. Where did it go? Oh, there it is. In my other one as well. It says object blob because I removed all the is binary logic. Let me add that back. Comma binary data is binary. Was this the logic? Let's look at the slides. Binary is binary. All right. Binary is binary, or you can just, I'm sure, default it to false and it will still work because we're not sending binary data, we're sending textual data. Let me restart. I've just reverted the code to what it was here. And then if I connect from here and then connect from here, it says 2 clients are connected because one is connected here in browser 1, another is connected here in browser tab 2. If I send a message from the first one, hi from client 1, send, I get it back, and then the other user also gets it back. We have created a real-time chat. This guy can send hi from client 2. It comes back to me. I also send it. I also get it back. Other guy also gets it. This is how you can do two-way communication. I am sending messages to the server. Server is responding back to me. Server is also sending the same message to another client. Very common way to build a multiplayer game, a multiplayer chat system, so on and so forth. Is this clear enough? Because if this is, then we'll be moving to something more interesting. Are we good to go, guys? Do we understand this? Oh, not a lot. Okay, we will take a pause. Let me answer question. I'm sure there's something obvious I'm missing. What's up? I'm looking at Q&A. Not working in Express. Not able to do this in Express. Export is not working. Recap. All right. Let's first try this in Express. Let's go back to this thing right here. Let's copy the code. I did not test this. Oh, no, I did not test this, but I think it should work. Let's see. Let's copy the Express code. Let's paste it here. Let's run a npm install express and at types/express. Let me run tsc-b to compile the code. Let me run node dist/index.js to run the code. It's a long running process. It is running on port 8080. It might not work. I did not test this. There's a good chance it doesn't work. If I connect, it does say connected for me. If I go to the other one, connect, it does say connected for me. I get back a hello message from server. Let me send. Oh, it says disconnected. As soon as I send a message, an exception comes. WebSocket is not defined. Let's see. There you go. It does not work because there is a bug. What is the bug? WebSocket is not defined. Can you import it? Yes, sir, Kirat, we can. Should it work now? Probably should. This was never defined, which is why, you did not sort of, this line sort of crashed. I just imported it from WS. I think this is where it comes from. Let's try that one more time. Connect. Hi from client 1. I get back hi from client 1. Other person also gets back hi from client 1. So what was the bug? When I was copying code around, I forgot to import this from the WS library. Other than that, does everything remain the same? I import Express from Express. I create an HTTP server. Forget all the other logic I have written. Just focus on these 4 lines. app.get / rest.send hello world. Very simple Express application. Remove all WebSocket logic. Import Express from Express. Const app equal to Express. If there's a get request here, send them hello world. And then app.listen 8080. Don't even worry about assigning it to a variable. Simple stuff. Done this many times. If I start this, what happens? Localhost colon 8080. If I go, I get back hello world. If I go to a random route, it says cannot send a get request to /AST. If I go to this, it says hello world. Very simple HTTP server using Express. Now what do I say? I say I will also create a WebSocket server. Const WSS equal to new WebSocket server, where the server is which one? This HTTP server over here. Given that we have this HTTP server, you write this logic. You only have to write this once. I know this can be a little jarring, but eventually you will see, whenever we create a big application, let's say we create a game, then you just send this request to another request handler. This much is your code usually, data, something like this. And then, request handler exists someplace else. So your boilerplate code is this much only. Your request handler has the meat of your logic. Okay, if the message was, move, if this is a real-time game, if you're creating something like this, the message that the client will send you will be something like, okay, I have moved up or I have moved down. So, your request handler will have all the logic to handle it. Your index.ts file won't look this big and ugly. But since right now we're not writing any application logic, we're creating a simple chat app. This is what we've written. Whenever there is a connection, if there's an error, log the error, remove this. Whenever there is a connection, control should reach here. What does control should reach here mean? It means your JavaScript thread will reach over here and it will have access to a WS variable. Anytime there is a message from that client, control will reach here. You don't have to do anything complicated. Simple. I received a message from the client. That's all. And you just log it on the server. You don't send it back to anyone. If the user sends me a message, server logs it, and then remove this as well. Let's create a very simple application. Let's create something like LeetCode, where the user, rather than sending you messages via HTTP, will now send you a message via, this message layer. So less than 19 lines of code. But Kirat, why would the user do this in LeetCode? Why would they not send a GET request or a POST request? Theoretically, I get it. They would not. They should probably send an HTTP request. But let's say you want them to send whenever the person is on LeetCode and the person is solving a problem and the person clicks on the submit button or run button, you want them to send the data from a WebSocket connection. Theoretically, let's say. Then we're just logging it right now. Of course, eventually you would put this in the database, do a bunch of things, but we are just logging this. This is very simple WebSocket logic. Create a WebSocket server. Whenever there is a connection, for that specific connection, whenever there is a message, log it on the server. Let me try to compile and run this. Try to go through this and marinate this code, specifically these 6 lines of code, for like 15 seconds. Then let's try it. Then we'll do another poll. This does not really use the power of WebSockets. It's not doing server side events. It's not pushing data from the server, but you can always write that logic, okay, ws.send whatever. But cool, we're not doing that right now. Simple, straightforward, just receive messages from the end client, log them on the server. If I run this code now, let me put this in the left, put this on the right. If I go here and connect, anytime I send a message, it gets logged over here on the server. Send messages, server is logging them. Very similar to HTTP, only I'm not sending a new HTTP request every time. I've created a single WebSocket layer. If I disconnect and reconnect, go to the network tab, I have a single WebSocket connection. And as I send messages, let me send a few messages. I'm sending all the messages over the same WebSocket connection. I'm not doing a fresh handshake every time. I'm not sending multiple requests. Single request mein I'm resending data again and again. And what is the server doing with this data? Right now it's just logging the data. Can it do more? Yes. It can respond back to the user. It can send messages to other WebSocket clients that are connected. It's not doing any of that right now. But do we understand WebSockets and implementation in Node.js? %, 83%. Good, not great. But as always, 15-20 more minutes of class, then questions at the end. So let's try to wrap up because there's not much left after this, I think at least. So give me some time to wrap this up and then I'll take questions at the end. I'm sure if you go through the recordings, you'll be fine eventually. Okay? Let's go through the client side code next. And then, as I said, questions from 8:40 onwards. I think we'll be done with the next 20 minutes or so. Cool. Let's proceed to the client side code. Given you have a server, as I said, the server can be connected from a browser. Let's say, a React app or a Next app, or from Postman, or the thing that we just connected from Hopscotch, or from a mobile app. Question is, how does a React application connect to the server? How can I create a game very similar to, Gather.on? How can I create a chat application very similar to any chat application you might have seen in the past? The answer is, as I said, when you create an HTTP server, when you created an HTTP server, how did your browser talk to it? How did your React code talk to it? How did your normal HTML code talk to it? Harkirat, I used the fetch API. The browser provides the fetch API, or we use this library called Axios, which also under the hood uses the fetch API. So Harkirat, for HTTP connections, I use the fetch API. And similarly, if you have a WebSocket server, you can use the WebSocket API. If you search for WebSocket over here, it already exists. It gives you very nice constructs to connect to a WebSocket server. Let's see how that happens in a React application. For a React application, let's quickly initialize one. First, make sure you have a Node.js server running locally. Make sure you have a Express server running locally, preferably an Express server that, has the same code over here or over here. If you're using this code, make sure you import WebSocket from the WS library, or you can use this code as well. Copy that code and paste it, restart the WebSocket layer and create a React project. Maybe right next to it. Maybe not. Right next to it is fine. Just create it, create a fresh project, create here, does not matter. The reason I don't want to create it separately is because if you close this, then, this will also close. So yeah, pick and choose how you want to do folder management, but I am just going to create it inside the backend project, which is something you shouldn't do. You should have, a root folder which has the backend code and then the front end code, monorepo style. But what am I doing? Let me also do that. That's fine. Let's start the WebSocket server in a terminal. Let's start it in a separate terminal so that we can open the React project here. So let me open a terminal over here. I am already in week 9 WS. I'm going to start the WebSocket server here. The WebSocket server is running. Now I will create a fresh React project in a different folder and open that in Visual Studio Code. Hopefully that is clear. This one is running the WebSocket server. Let it run because we have to connect to it. Backend is running here. Front end we are going to create now. So first create a fresh React project. npx create Vite at latest. npx. I think it is this. I could be wrong. It is something else. What is it? npm create Vite at the rate of latest. My bad. npm create Vite at the rate of latest will create a fresh React project. Call it React WS. I already have that. So let me name it React WS week 19 and select React as the framework that you're using, TypeScript as the language that you're using. Let me go to React WS week 19 and open this in Visual Studio Code. Would urge you to do the same. Create a fresh React project, open it in Visual Studio Code. Then run npm install to make sure all the dependencies are installed. You don't see the red squigglies that I see over here. We'll wait for 2 minutes before I proceed. All right. Dependencies are installed for me, but I'll take a break. Let me look at Q&A, just initialize the React project until then. How to persist socket data in DB? Example, persisting group chats. How do you think? Just store wherever you have the request handler. For example, here you have it in here. Whenever you're getting the data, just do a Prisma call over here. You can optimize it. You probably don't want to do DB calls here. You want to again send it in a queue and eventually, have the database be eventually populated, because a lot of people will send chat messages. You don't want a lot of DB calls. You probably want to bulkify the DB calls. So you can do a bunch of optimizations, but the simplest approach is do a db.store over here. How are we differentiating every user? You don't care about the platforms they connect from. Every client, you will have a client ID. You will have a, this client.id, a way to identify them. They might send a first message that shares their cookie, shares their token, so you can identify them on the server. And then, eventually, every other request you can identify. Okay, so this is this person. We will not be covering nests here. How does Hotspot know to subscribe on messages to send the messages? I think you are coming from the Socket.io world. Question that you're asking is, how does it know the message, it needs to subscribe on messages? This is the only thing that WebSockets send. You send a type message, you get back a type message. You can't change this to, event 1, event 2, like Socket.io may you can. So I think the reason you're confused is because you've used Socket.io in the past. Both you send the callback says any message that is coming will come here. And whenever you send back a message. There is no different types of way to send, very similar to Socket.io, where you can be like, socket.on A, socket.on B. Can't do that here. How can I send messages to the specific user like WhatsApp? Yeah, you iterate over all the clients and then, find that specific client and then do a client.send for that user. Eventually, this will come in some project. This will come when we build whatever, Zerodha, you can get this question will get answered there. All right, cool. Can I proceed? Do you have the backend running locally? Do you have a simple React project started locally? Are we good to go? So whenever you have a React project, what do? We go to app.tsx and remove everything. सबसे पहले तो we don't want any random logic here. Then we do put routing over here. We have React router DOM, all that jazz. We're not going to do any of that today. We'll put everything in app.tsx. Ideally, you should have a chat component if you're creating a chat application. And there you should create the socket connection. I'm just creating everything here. Create a state variable called socket. You don't really need it right now, but let's create it. Socket, set socket equal to useState null. It is null initially. Harkirat, why? Why is it null? We'll see. Well, very soon we will see. Initially it's initialized to null. And you can also be like, if not socket, then return loading. So that while the socket connection is being generated, the user sees a loading. And then create an effect at the top, a use effect that runs whenever the component mounts, which means, the first time the application mounts, to create the actual WebSocket connection. Const socket, AI is helping me out too much here, but chalo. Yeah, there you go. I'll go over it one by one. Let me just type it out myself. Const socket equal to new WebSocket. Harkirat, where is this coming from? You did not import it. It is natively present in the browser APIs. Just how you never have to import fetch whenever you're sending a fetch request, you don't have to import WebSocket. Harkirat, I had to import Axios. Yes, Axios is an external library that you have to import. But fetch you don't have to import. WebSocket you don't have to import. You create a WebSocket connection, and then what do? Socket.onOpen. When the connection gets completed, you have an open connection. We're just logging connected. You can do a bunch of things. You can, ideally here you should do set socket. You should set the state variable here. Okay, now you are connected. Now the loader should go away. The user should see a loader until the socket connection is actually open. If I do this, if I do a set socket outside, then the effect will run even when the socket is not open. The user will see the final page. Shouldn't happen. User should see the final page only when the socket has been open. So you can ideally say something like this: connecting to socket server ... something like that. And when the connection opens, you actually set the socket variable. You will see a type error over here. The type error says argument of type WebSocket is not assignable to parameter of type set state action null. It's basically saying, yaar, you told me the type of this is null. How are you trying to set a WebSocket instance on it? And the answer is, whenever you're creating it, you have to pass the types that this can have as a generic. This can either be a null or can be of type WebSocket. That is how the red squiggly will go away here. Whenever you're initializing useState, you can pass the types that it can become. It can be null or it can be WebSocket. It is initialized to null, but eventually gets set to socket. Whenever the socket is open, you log connected, and anytime you receive a message from the server, you log message received. Harkirat, you have written the logic. Okay, when the server responds, we log something. How can I show that thing? You can just put it in a state variable, right? You can be like const messages, set messages equal to useState empty array. And then whenever you receive a message, you can be like set messages m ... m message.data, something like that. What did you write over here? Basically means append to the set messages data. If you don't understand this, you can also just be like, const latest message, set latest message equal to empty string. And anytime a message comes from the server, you can be like set latest message, message.data. Whatever data came back, I'm just going to set it in this state variable. And let me write this state variable here as well. Latest message can be rendered over here. Initially, it will be empty, but as the server responds back with more and more messages, when does this run? When does the control reach here? The control reaches here when the server sends you a message. Very similar to when we were on Postwoman. Oh, it went away. But when we were on Postwoman or Hopscotch, we were seeing a bunch of messages here, right? If I connect, the server is down, node is /index.js. If I connect, I got a hello message from server. Whenever I receive these messages from the server, control will reach here on the client. On Hopscotch is also a client. And what does this guy do when it receives a message? It puts it here in the queue. What do we do? What does our browser application do? Whenever we receive a message, we set it to a state variable, which gets rendered eventually over here. So that is how you create a simple application. Harkirat, you have written the logic to receive messages. How can I send messages? You have access to the socket variable. You can just be like, have an input box followed by have a button that says send. And you can be like on click equal to socket dot send whatever message you want to send, whatever is the input body here, or hello world. So that is how you can send data from the backend as well. Sorry, the front end as well. This is how you can receive data from the front end. So if you look at the whole code one more time from the top, I initialize a socket variable. I added some extra types over here to make sure we don't have any red squigglies. If you're using JavaScript, you don't need to add this. You can also always just use the any type if you don't understand this. Then we say initialize it to null. And while this is null, if not socket, the browser should say connecting to socket server. The user should see a loader. Okay, we are still connecting, wait. Then we have a use effect that says anytime the component mounts, create a fresh WebSocket connection. And anytime it opens is when you actually set the variable. Okay, by the socket connection has opened. Now we can get rid of the loader. Now we can show the user an input box and a button where they can start to send messages. If you don't do this, then the user will try to send messages and it will throw an exception. I haven't yet connected. The connection isn't open. So we make sure only if the connection is open, we set the socket variable. I can remove this last line. And then whenever we receive a message, currently we just log it and set it to a state variable, which eventually gets rendered here. So as the server responds, my user will see the latest message. Let's see this in action. npm run dev. If I open this, it shows me the message. Hello message from the server. Harkiya did not show me the loader because the socket connection got created immediately. If I add, some artificial delay here, set timeout. Oh, you can't await here. You get the idea. If I add a artificial delay here, if this takes a really long time, if on open takes a really long time, then you will see the loader over here. Since it's on my local machine, the WebSocket server is on my local machine. It happens so quickly that you don't see a loader over here. I can send messages by clicking on send, and whatever message I'm sending, the server is responding back with a hello world, which is why I see hello world over here. Harkirat, where is this logic? If I open, what did we write? We said whenever there is a message, client.send back data. Oh yeah. Send back the same data to the user. And what is the user sending? Currently the user is sending hello world. How should you update the application? You should, add a third state variable. Call it const message, set message. Use state empty. And then anytime the input changes, on change equal to set message e.target.value. And then socket.send should say message. Send whatever is in the input box. Whatever is in the input box, send that to the server. The server will respond back with the same thing. And you will see that, in the state variable. So if I save this and refresh now, my server died. Let me restart. Refresh. I see one client has connected. Let me connect another client. Let me open this in another tab. I have two clients connected. Let me send hi there from here. Hi there from client 1. Send. I get back hi there from client 1 here. The other person also gets hi there from client 1. So The message is being broadcasted to everyone. Have I created sort of a chatting system? Yes, I have. Send some message, comes back here as well. That is how you write client side logic. In React, very similarly, you can write it in a simple HTML CSS app. You can write it in Next.js as well. The one thing you should do is, clean up in the effect, do a socket.close here, because when you're running React in, strict mode, this gets run twice. What if this component gets unmounted? What if the user is on your website and they go to a different page, the non-chat page? The WebSocket connection should close then. So that is why you should do this cleanup as well. But that's pretty much it. I'll take a pause here. Do we understand how to add it in React? Because if you understand this, adding in Next.js is a piece of cake. We do understand this. Beautiful. So we're at 8:33. We can actually go through Next.js, but we can also answer questions because Next.js is fairly simple. Let me take you through it really quickly. In Next.js, just create a fresh Next.js project. Update page.tsx to be a client component. The only thing you have to make sure is, if you are using WebSocket logic, make sure it is a client component. Why, Harkirat? Because if you don't make this sure, your next server, I repeat, this is your next server and this is your end user client. Your client will be like, okay, can you please give me my landing page? If you don't make the specific component that is using WebSocket a client component, what will happen? Your next server will create a connection to the WebSocket server. We don't want that. We want the end user to create a connection with the WebSocket layer. So the only thing you have to keep in mind is, especially if you're using, client server components, is make sure it's a client component wherever you're creating a WebSocket connection. I did not try this without a client component. If I had to guess, one of two things will happen if you don't make it a client component. Either Next.js will complain. It will be like WebSocket is not supported on the Next.js server, or it will create a connection between the Next.js server and the WebSocket server. If someone has tried that, let me know what happens. But yeah, other than that, everything is exactly the same. Your page.tsx has logic that looks like this. You can have an effect that, creates this. There was another call out here. Okay, you can actually convert this to a custom hook called use sockets. Something like this, function use socket, to make your logic slightly cleaner. Yeah, the only problem there will be how will you set the state variable. Maybe you cannot do this. Yeah, you can basically do something like this, and then this will be somewhere else. You can create a custom hook called use socket, which has all of your use effect logic, socket initialization logic, returns the socket, and you can simply be like const socket equal to use socket over here, and then you can add an effect over here that does this socket.on message, do whatever you want. So, but yeah, I'll pause here. The only thing that's left after this was scaling WebSocket servers. It's fairly straightforward. Whatever you think from first principle is the right way to do it. This was done at GatherTown. This was done at Backpack when we had chat. This was done at Backpack Exchange. This is how you scale WebSocket servers. You scale them horizontally. The thing about WebSocket, if you have 1 million users, Mano, this is 1 million users. How many HTTP servers do you need to support them? Not a lot. Why, Harkirat? Because not 1 million of them are sending requests together. Maybe 5,000 are sending requests together. If there are 1 million users currently active on leadcode.com, not everyone is sending a request. I sent a request initially. Now I'm just chilling. I'm just, scrolling the page. I'm not sending any more HTTP requests. Whenever I change the page, I will send some more HTTP requests. So scaling HTTP servers is much easier. You don't need a lot of HTTP servers to support 1 million users. But if you have 1 million users in a real-time application where there are WebSocket connections, then your server fleet needs to, be connected to 1 million users. A single server won't be able to handle this. You are persistently connected to everyone. There are benchmarks around, how much can a Socket.io server support? How much can a Node.js WebSocket server support? I think it's around 10 to 20K users. You can't support more than that. If you have 1 million users and you have a WebSocket server, you will need a fleet of WebSocket servers. A single WebSocket server won't be able to support it, especially if you're using Node.js, where, most probably it will be on a single core. If you're using Rust on, on a 32 core machine, then you probably might be able to support more. But yeah, a single machine running Node.js can only support, 10 to 20,000 users. So if there's 1 million users, you probably need, 50 to 100 servers. So that is how you scale WebSocket servers. The problem comes when these sessions are sticky. I repeat, when these sessions, these are 1 million users, first 10,000 users are connected to WS1. Second 10,000 users are connected to WebSocket server 2. Third connected to WebSocket server 3. Now let's say this guy sent a chat message. This guy sent, "Hi there," and one of his peers in the same room is on another server. There is one user connected to WebSocket server 1, another user on the same room connected to a different WebSocket server. How will you transmit the message from here to this WebSocket server back to this user? I repeat, if you have sticky, or if you need sticky connections, what are sticky connections, Harkirat? There might be, 50 people in the same room. Sticky connections means you will make sure even if there are multiple people, one present in India, one present in US, one present in UK, if they are part of the same room, if they are part of the same, you can go to gather.town and create a room for your team, your company, and all those people will be part of the same game. I hope you understand what a room is. It's like a chat room. It's a place where messages need to be transmitted to each other. For example, in this room, there are 1, 2, 3, 4, 5, 6, 7 people. One of them is a Sardar, so cute. So we have 7 people here. All 7 people can either be part of the same WebSocket server. Believe it or not, that is how it happened at Gather until I was there. Whenever a new room was created, all the users were connected to the same WebSocket servers. It was known that they don't support more than 200 users. A single WebSocket server can support 200 users. So, they would create sticky connections. Doesn't matter if you're from India, US or UK, you will all connect to the server in UK, let's say. This is one way to scale WebSocket servers. This is called sharding. You are sharding the users. Based on your room, you will be connected to the same, WebSocket server. And we don't want to horizontally scale this. And, that will just complicate things. So if you're in the same room, you're all connected to the same server. This is one ugly way to scale WebSocket servers, by sharding them. By people in the same room connect to the same server. What is a better way? Doesn't matter what room you are in. Doesn't matter what room you are in. If you are in UK, you will connect to the UK server. If you are in US, you will connect to, let's say, the US server. And if you are in India, you will connect to the India server, even if you are in the same room. This is a better way to scale. What is the problem in this? The problem is, if I move up on this GatherTown page, if I move from here to here, this message needs to go from me in India to my server in India to a server in the US to my peer who's connected to the same room in the US. It needs to go from one WebSocket server to another, which is why this is harder to scale, but the better way. Why is it better? Because I can be close to my India server, US person can be close to their US server, UK person can be close to their UK server, and you can scale beyond 10,000 users. If you have sticky connections, if you're putting everyone in the same room on the same server, you are restricted by 10,000, that number. You cannot have more than 10,000 people in a single room. But if you want to have a very big application with 1 million users in the same room, is when, this architecture works better. Harkirat, how would this architecture work? There are multiple ways. The most easiest one is you create a pub sub. Whenever a person from India connects, they tell this server, hey, I am part of room 1. WebSocket server tells the pub sub. Pub sub stands for publisher subscriber. We'll probably discuss this today. It tells the pub sub, bhai, I am subscribed to room 1. If someone sends you a message on room 1, tell it to me so I can forward it to Harkirat in India. And let's say Alex connects from US. Most American name I could think of. And he also says, bro, I am part of room 1. Now, anytime Alex sends a message to the second WebSocket server, the WebSocket server publishes it to the PubSub, and then the PubSub is like, Acha, who else needs the messages from room 1? India server, you need one? There you go. Alex has sent hi. And then the hi reaches here, and then you send it back to Harkirat. That is how you scale horizontally the better way, by not using sticky sessions. Both are fine approaches. Gather was valued at $1 billion, still use it, the sticky approach. It worked for Gather because, there was a very big restriction of 200 people per room. Because if you have more than 200 people, it's very hard to support audio. And this app supports audio as well. People can talk to each other. So for them, it made sense. But if your application needs to grow beyond 10,000 users like Discord, then you probably need, a distributed system that's non-sticky. But with that, I will do a poll and then I will answer some questions. That was probably the class for today. Tomorrow, let's do message queues, pub subs, create some, maybe try to create a system like this. But yeah, all right. That was pretty good. 92% is great. Let's look at Q&A. I'll just open chat, I think. Please share code of WS in React. It's right here. Create a fresh, I can push it to GitHub if that's what you want. But yeah, it's right here. Just create a fresh app and then, replace app.tsx with this code and you're good to go. All right, I'm going to open chat. Let's just answer. Easier to track questions there. All right, any questions, guys? A lot of questions. We'll wait. And okay, let's see. Notion doc. Mine is disconnecting. I'm trying to use HTTP only on Hopscotch. Do you see any server logs? Is your port correct? How else can you debug? If you look at the server logs, is your server crashing? Most probably it might be. I missed some classes about this Web3 cohort. Where will it start? Unsure right now. Why are you dancing so much today? I don't know. Am I? How it works in group in multiple users? What does that mean? Can you elaborate on the question? Should we learn about Socket and WebSockets? Is it not worth learning Socket.io? There's nothing to learn in Socket.io. If you know WebSockets, you'll understand the code of Socket.io, vice versa. So both are fine. How do I create rooms and one-on-one connection between two clients? Yeah, so as I said, Socket.io lets you create rooms very easily. This does not. If you look at the Socket code, especially the server code over here, there is no easy way for you to create rooms. You have all the clients, like all the people currently connected on the wss.clients array. But you have to tag them. You have to maintain a global variable that will store this client is in this room, this client is in this room. If you want to look at a repository, we actually did this in a YouTube live. So if you go to real-time chat app, you will see the index.ts has, a user manager. You create a user manager class. This is like a little too optimized. You can just create a global array or global object where you store, this user is part of this room, this user is part of this room, and then you broadcast the messages correctly. If you want to look at some code, this is the code. It will be hard for you to understand if this is the first time you're learning it, but this has, a lot of the logic that you're looking for. How to create rooms or, one-on-one messages. Notion doc. Can I create rooms and one-on-one answer that? How to make project from React and Node.js? How do I find ad hoc startups? How much the price of Web3 code? Price, I don't know. How to make projects from React and Node.js? How to find ad hoc startups? Ad hoc startups usually come on Twitter, and projects. I'm assuming your question is how do you find projects? I don't want to name one, but मैंने कई बार बोला है. There aren't a lot of people on the call. Dub.sh is a great one to look at. That guy's also pursuing it full time now. I don't know if he's hiring, but that code base is prime. If you look at that code base, that's pretty good. And then, a lot of code that we are writing is also, the same that's written in a lot of companies that use that specific stack. Lua file for NeoVim, I made 0 changes from LazyVim. Exactly the same. I'm about 20% your coding speed. How to grow coding speed? So yeah, it comes from a lot of practice. Write a lot of code and it naturally comes. I've never used, TypeRacer other than, with friends. There's no hack around it. You just, over time it happens. WhatsApp clone. Probably one of the best clones for WebSockets. WebSocket versus WebRTC depends on the application. For example, if for GatherTown, as people are moving around, people move around very often. This person might move around everywhere. Does it matter if a few events get missed? What if this person moved here, and a few events got missed in the middle? It's fine, because as long as their eventual location is transmitted, it's fine if a few events get missed. So for an application like this, WebRTC might work. Why? Because WebRTC happens over UDP. It can happen over TCP as well, but UDP, you can send it over UDP. The benefit of UDP is it happens faster. The downside is a few events get missed. But does it matter if this chat bubble that's coming on top? Does it matter if you don't see it? Doesn't matter. So, it is a choice. You would use WebSockets when you need TCP, when you need to make sure the event goes to the other place, like a chat system. You can't miss a chat message. But can you miss a movement message? Yes, you can. If the person is moving around very quickly, send all the data via UDP or WebRTC. When they stop for more than 2 seconds, then send the final message via TCP or WebSockets. And that's, how you can decide whether to use WebRTC or WebSockets. More questions. I'm looking at the Notion doc very soon. Notion doc. Answered the room's question. Can we spoof messages event sent to client another way? Can we spoof message event? No. Also run you can just how you create an HTTPS layer on top of HTTP on EC2 machines on AWS. How did we do it? By creating an Nginx server that has your certificate and runs on HTTPS. I have not done that video. Certbot video I haven't done, but just how you convert an HTTP server in Express to HTTPS, you can convert an HTTP WebSocket server to HTTPS. The steps are exactly the same. How does a game like Counter-Strike or FPS work? Great question. There is one extra thing that happens in these games. Everything else is the same. If there are 100 people currently playing Counter-Strike, firstly, they have sticky sessions from what I know. Why do I know this? Because, a few friends used to play it in college and they used to say, bhai, maine server bana liya. I have made a server is what they used to say. So I think there is the concept of a sticky server. Whenever you're playing Counter-Strike, everyone is connected to the same WebSocket server or, real-time server. Maybe they don't use WebSockets, they use something else. But everyone is connected here. The extra thing that happens is there is some game logic on the server. I repeat, the server itself stores, when you send it a message, right? I am moving up. I am moving forward. The server maintains that Harkirat is at 2,3. And then someone else does the same thing. It maintains that Aman is at 2,4. Raman is at 2,4. So on and so forth. Why, Harkirat? Why do you need to do this? Because what if the person tells you, nahi, I am at 200,200. They can spoof events, right? So everything needs to be maintained on the server. And especially when you shoot, I repeat, when you shoot someone, I don't know if I should say this in class, when you try to play with someone, whatever, you get the idea, you shoot someone, you send the server the logic, the message that says, I shot person from position 2,3 or wherever you are with this rifle. And then the server will calculate, does this mean the other person dies or not? The server is the source of truth, because you might be on a very bad connection. You might be on a very good connection. What if you send, shoot, but your, opponent moved a bit? Who decides? Everyone needs to have the same state. When you're in Counter-Strike, if there is some latency between this guy and this guy, and you said shoot, and this guy said, Acha, Harkirat shot from this position, but this event reached this client after 2 seconds, then the person would have moved. So this person will feel like, he did not die. This person will feel like he died, so on and so forth. So the one extra thing that happens is the server is the source of truth for a game like Counter-Strike, where when you shoot someone, the server will be like, based on the current positions, this person is dead. And it will tell everyone this person is dead. It will not tell everyone shoot 2-3 rifle. It will not tell everyone shoot 2-3 rifle. It will tell everyone a shot was made, whatever. But it will also decide whether or not the other person died. You will not on the client side decide कि अच्छा shot हुआ है तो other person की position ये है तो it will die or not. The logic to whether or not someone has died, whether or not you have picked up a bomb needs to happen on a server. So yeah, that's what happens in real-time games. When you create real-time games, the only extra thing that happens is your server maintains a lot of logic. Your server is the source of truth on who won and who lost and who shot and who got shot. And your clients never decide that. Your clients are never like, acha, shot happened from here, so I will decide is the other person dead or not. So the events are a little extra than just broadcasting it to everyone. Good question. You should read about multiplayer games. Most multiplayer games are made like this. How to answer that? Socket.send and client.send in the server code. So firstly, it doesn't matter if you call it socket or client. It's written client over here. You can call it socket. Let me make this even easier to understand. If you look at the WebSocket server, if you ignore all of this logic for now, this WS variable is one thing. The WS variable is one thing. As people connect to you, I repeat, if this is your WebSocket server and this is a client, a browser that connected to you, as soon as they connect, as soon as the WebSocket connection is open, control will reach here. You will have access to a WS variable, a socket variable. You can call it whatever you want. And यहाँ पे you can be like, यार, as the user sends me messages, as the user sends me hi, hello, move up, move down if this is a Counter-Strike game, control will reach here. I should write logic here to, write to the DB that the user has moved. If this is a Counter-Strike game, if this is a chat game, then write to the DB that a message has been added. That's the logic you should write. What else should you do? You should tell everyone कि यार Harkirat has moved up a bit or Harkirat has given a message. So what do? You iterate over all the clients. There might be other people connected, right? You're not the only person who's connected to the Counter-Strike game. Your friend might be in the same room. Another person might be in the same room. So what do? You iterate over all the clients, ws.clients or whatever the logic was. WSS.clients. You can also maintain a global array. You can be like const connected clients equal to empty array. And then यहाँ पे you can be like, whenever a connection is made, connected clients.push WS. So you can maintain your own global array. You can also tag the users with this person is part of this room, something like this. Okay, the type of this array is WS, the WebSocket connection, and then room, which is string. So as people connect, you can store their WebSocket logic as well as the room they are in. For example, Counter-Strike room 1. Not push. Append hota hai kya? Oh, sorry. Array. And then when someone sends you a message, okay, bhai, I want to send, this data to this room, you can get all the users in that room. Okay, bhai, connected clients dot, you filter all the people in that room or whatever. And then for each, and then for every client, you send the message. Client.send, Harkirat has moved or whatever. Client.ws.send. Only if client.room equal to Harkirat room, something like that. So yeah, the client.send or more specifically the ws.send is ke bhai send this user back some data. Whenever someone sends you some data, you broadcast it to everyone. That is what this logic does. Okay, for every connected client, where does connected client get populated from? From a global array that I've created over here. I've given it a type, which is why it might seem, difficult to understand, but you can give it an any type. Okay, bro, doesn't matter, very simple array. Whenever someone comes, add them to this specific room, and this can be based on some logic based on ws.current route. You can, like, when the user connects, they can also send you, okay, I want to connect to room number 1 or room number 2. They can send you their cookies. So you can do all that authentication logic here. And then, anytime there's a message, you just broadcast it to everyone. Does WhatsApp use WebSockets? I think so. I have read this somewhere. Most probably they do. Like 99% they do. How can we do something similar in Postman that we didn't Postman? I don't know. I don't know if Postman supports real time. Someone told me recently they do. We can try to figure it out. Like, this is how I would figure it out. I would just open Postman. And then, yeah, I don't see anything here. Let's see. Post get. There is a way. I'm sure there is a way. I don't know what is the way, but there is a way. I mean, maybe there's not a way. I don't know. Maybe it happens after you sign up. Lightweight client, explore. Yeah, just Google it. If there's a way, you'll find it. Else just use Hopscotch. Open source repo allow us to look at the code structure of WS if possible. Standard WebSocket in Node.js and in open source repo. I mean, depends on the definition of an open source repo. I showed you the real-time server. That has a pretty decent, architecture. If you want, you can look at it. A lot of this was in Backpack. It got removed eventually, but yeah, it won't be here now. But this also had Backpack had chat at some point. A lot of this logic was there. Is there another repository that has WebSocket logic? I can find one. I showed you one already. That's also pretty complicated. If your goal is to learn, so you can just go here and try to look at how user manager things like these are structured. This is also a lot of code. So yeah, there is a message handler that I pretty much shared. Whenever there is some data that comes in, connection on message, it goes to a message handler that actually checks. Oh, is the type of message join room? Is the type of message send message? Is the type of message upvote message? What we were building here was something like this. We wanted to create a chat system where people can come and send doubts, and then a lot of people can upvote, and the most upvoted doubt is what comes here to this other section that the educator can look at. That's what we were trying to build. So yeah, you can read through this code. Let's say Among Us game chose either server in Asia, US, UK, and they'll join the room, and so that will mean most use sticky connection. Yes, I would assume so. If you have less than 200 users, Among Us has 5 users, you will most probably, there's no point distributing it. That's over engineering right there. If a company that's worth $1 billion is not doing it, why would you want to do it? I'm not saying it's not optimal. It is optimal. The optimal thing is that you don't have sticky connections. You have a distributed WebSocket layer. But do you need it for 5 people? No. For example, if you're creating a WebRTC call, if it is between 2 people, if it is something like Omegle, person 1 here, person 2 here, should you use peer-to-peer WebRTC? Yes. Can you create a distributed SFU architecture? Yes. Should you? No. This is good enough. It will give you a lot of benefits. It will give you lower latency. These guys will be directly connected to each other. They'll share video directly with each other, so on and so forth. If you're creating something like GatherTown, where in a single room there are 100 people, sometimes 1,000 people talking to each other, sharing video, then you should do distributed SFU architecture. So it's about the choice that you make. With that, oh shoot, I closed all the Notion docs. Let me open them again. Oh god, Zoom is so hard to navigate. Okay, there you go. REST versus GraphQL. It's just different ways. How does REST work? You send a post request with some body and some headers to the server. GraphQL gives you a different way to send data to the backend, a specified way. Why is it beneficial? It is beneficial because if you're using GraphQL and if you have a lot of relationships in your backend, you don't have to round trip. Okay, what is an example of this? Good example is if you are creating Facebook or even better Swiggy, any application, when the user first comes to the website, swiggy.com, you usually send to the server, bhai, what is this user's details? You get them back. Then you send a request, what are the restaurant's details? You get them back. Then you send a detail, his order history, you get them back. You do a lot of round tripping. Versus, what if you could describe to the server, okay, yaar, I am a browser client. Please give me just the name of the user and the order details, which should have, the order type and the restaurant name and give me, the current restaurants. Give me their name and their rating. What if whatever client was sending a request can be like, if this is the GraphQL server, can be like, yeah, I need data in this shape. And then, the mobile app might be like, yeah, I only need data in a different shape. I am the mobile app. I don't really need the user to see their order details. So let me just skip this. What if your GraphQL server had a single endpoint that could support both of these, rather than, you creating two different endpoints, one / API / v1 / web, and another endpoint / API / v1 / mobile. You create a GraphQL server. You tell the client, bhai, whatever you want, मुझे ना payload में दे दियो. Give me in the payload what you want. I will respond back with the same. This way you can minimize a lot of the things that the server is sending. If you have a single endpoint that, Harkirat, I will just have a single endpoint, it returns everything. You can. But then the mobile app is getting order details, which it doesn't need. It doesn't need to show it. So this became a problem at Facebook, because Facebook, very big company. वहाँ पे they realized कि, every client is sort of needs its own shape of data, less data, more data. So they created GraphQL. It just lets the user specify, okay, I want data in this shape. Server responds back without you having to maintain, 10 different endpoints for web, mobile, so on and so forth. Can you explain this? This. What does this say? It says, okay, bhai, ws.on error. If there is an error, call this function. You can either be like, okay, bhai, call this function with the error, which will do whatever. Error came plus error. You can either do this, or you can be like, okay, bhai, whenever an error comes, call this function called console.err. So what will happen? Whenever an error will come, it will call console.err. Rather than calling this function, it will call this function. You can also do this. Look at the function error callback. Rather than doing this, okay, bhai, whenever there is an error, please call error callback. We are saying whenever there is an error, please call console.error. So what will this do? Whenever an error will be thrown, it will call console.error with the error. So it just makes sense to do this, right? Why do you want to create a fresh function which then calls the same console.log or, console.err error? If this callback is just going to do this, and the argument here and here are exactly the same, then just pass console.error over here. You don't need to create a fresh function which will get an argument and then pass the same argument to another function. Just give the function name here. It will call it like this. WebSocket connection error. Error मुझे दिख नहीं रहा. Oh, there you go. Disconnected. Sir, you are creating a WebSocket server connection. WSS needs to be WS. Hitesh build application called Hello World. Very nice. High level overview about integrating timescale into a graph, fancy loading animations in our Paytm application dashboard. Have you made this? Very cool. Or are you just asking? Either way, high level overview is timescale DB is a place where you can give time series data. At this point, this happened. At this point, your portfolio value was XYZ, so on and so forth. And you can also tell it, here maintain a 24-hour chart, maintain a 3-hour chart, maintain a 1-hour chart, 7-day chart. It will cache all of those values for you. It will store them, in various databases or tables. Okay, this is the 24-hour chart for Soul, and this is the whatever, 1-minute chart for Soul, so on and so forth. And then when the user asks, because eventually the user will come to your, website like this, and they might be like, or a better example here might be CoinMarketCap. They come to your website and they might be like, I want to see the 1-day data. I also want to see the 7-day data. Okay, it looks like this. Let me look at the 1-month data. Let me look at the 1-year data. So you don't want, okay, there's a single database that has all the entries. You want to have a 1-year database, a 1-minute database, a 7-day database, so that this data is cached. You just get it from there. That is what time scale or the time series data databases help you with. Please do the code 100 or join, but I can't go. That makes sense. All right, more questions, and then we'll. Oh shit! I know 7. I have to rush. Notion question 1, Notion doc 2, doc 3. All right. Apart from early stage startups in JavaScript TypeScript is used in the industry in large orgs. And depends on the definition of large org. It is definitely used in front end everywhere. If you join Google, if you join Amazon, if you're writing front end code, you're using TypeScript. Back end code is tricky. In enterprise companies, probably not. I mean, we use a little bit of it in Goldman. So, it is very nuanced as to which company uses it, which doesn't. Java is more popular in enterprise companies, but big companies, for example, depends on the definition of big, right? Caldertown is big, $1 billion, but it does use Node.js. A lot of companies, are not worth a lot of them, still use Rust. So it really depends on the founding team usually. Is jumping between technologies doable? Yeah, I don't know why people worry about this too much. It's very easy to pick up a new stack. If you're very good in one, then you'll very easily be able to move from one to other. Most organizations have, most startups do. Organization is a big thing. Most important, how do you build your connections if you can't go to conferences? I never go to conferences, just in case. I go through a lot of open source code and talk to people there. It's very hard to reach a Bollywood celebrity. It's very easy to reach a coding celebrity if you contribute to their code base. If you contribute to Linux, probably able to reach the maintainer of it. If you contribute to Ethereum, you'll probably be able to talk to Vitalik. So it's actually, that's the best part, right, of tech. Okay, the biggest celebrities are actually very achievable, provide you code. And I hate going to conferences. Can you please give an overview of the graph section is built? The graph. Most apps like these use something called TradingView. So TradingView provides an API for something like this. No one's building this in-house. It's very hard to build this in-house. So yeah, and this has a very clean, easy API. They have a premium version, a free version to do this. So yeah, the graph is actually for a trading app like this delegated to trading. Everyone, I think, including maybe not Zerodha, but like most of them use this. How do you learn a new technology? New tutorials and courses available. Yeah. So this advice remains very concrete from my side. Okay, you learn a new technology by building something big in it. If you're lucky, you will find a company that's building something big in it. For example, if you want to learn AI, if you're lucky, you'll join a company that's early with very smart people who are building it, and everyone's figuring it out. It's not like there's a playbook for anything. How do you build a AI agent or whatever, a Copilot thingy? There's standard guidelines how you would build it from first principles. You will learn it very well if you're working at a company that's doing it, and it has founders that have background in it. So that's probably the best answer I can give. That's the best way to learn. But I get that not everyone can have that opportunity. But then the second best thing is just looking at open source projects and trying to solve issues there. What is between WebSocket server and WebSocket client? What is the difference between Express and Fetch? Express is a library you import on a server. Fetch is a request you send from a client. So what is the difference between a WebSocket client? It gets initialized in the browser. What is the difference? What is the WebSocket server? It gets initialized on the server. What is sticky connection? As I said, sticky connection is if you have a fleet of servers, if you have multiple WebSocket servers, and you have a restriction, your users in room 1 need to go to WebSocket server 1, then your connection is sticky. You need to make sure, if all of this is in front of a load balancer. I repeat, a lot of times you might have a load balancer. You don't give the end user, 3 URLs, ws1 dot something, ws2 dot something. You give them a load balancer URL, ws dot whatever, randomwebsite.com. Your load balancer needs to make sure request is coming for room 1. I need to send it here. If someone is connected to room 2, then where are all the room 2 connections? They're on WebSocket server 3. I need to send it here. So on and so forth. That's what a sticky connection means. In the real life lesson, you said message would be broadcasted to everyone. I'm confused because message should only be transferred to recipient, right? No. If you have a chat application, if this is my chat interface and I type hi there over here, this message should reach a WebSocket server and it should get broadcasted to everyone who's part of the same room, right? If someone else has a mobile app, they need to see your hi there message over here. And then if someone else has it, they also need to see it. So it needs to be broadcasted to everyone. What makes you think it does not? Can you answer that? Same question someone else asked. I have to think about this now. Okay, cool. Chat. Okay, I'll open it one more time, guys. I have a hard stop in maybe 5-10 minutes, but happy to answer quickly a few more questions. What is the difference between polling and DDoS attack in terms of handshake pattern? तो बहुत ही अलग चीजें हो गई यार. Polling is when there is nothing malicious in polling. If this is a WebSocket server, one of your browser is sending request again and again. This isn't malicious. This guy is just like, if you're on LeetCode, you're just asking, is my submission done? Is my submission done? There is nothing distributed about it. DDoS mein, what is the biggest word? First D, distributed denial of service. Harkirat, why is D very important? Because if the same person sends a lot of requests, you can rate limit them. You can be like, sorry, you've sent too many requests. When there is a distributed attack, when the requests are coming from various IPs all around the world together, is when it becomes a distributed denial of service attack. Here you maliciously send requests again and again and again. That is what DDoS is. What is polling? Yeah, can I get some data? Okay, cannot. Can I get some data? Okay, cannot. You're not distributing and targeting a server. You're just trying to access their servers. You are being a little impatient and sending a lot of requests, but that's fine. You can always be rate limited. When you do a distributed attack, it's very hard to rate limit because messages are coming from so many IPs. So, that's why DDoS is different from this one. Oh shoot, I lost my chat. Also, I'll stop sharing. Can we please skip 1 week class? I think I'll do a poll. I think most probably people will select, let's skip it. Before 100, we will do it. Even though this is like sort of the beginning of 100, but yeah, I think next week will be a holiday most probably. We'll do a poll. There you go. Postman supports WebSockets now, so you can read at that blog post. Honest feedback, please consider. Let's consider. Static site generation with dynamic routes. Yes, I read this. Someone posted this, which leads to this. To cache dynamic routes during build, added this. Does not cache for MCQ or code type questions. Problems, only Notion blogs. That makes sense. Oh, you added a code. Can you just create a PR actually? And also, like, can it not do it for MCQ questions? Can you not have a part of the website statically generated? The answer could be no, but I think you can. I could be wrong. Okay, if this is an MCQ question that I open, also just create a PR and happy to create a bounty for this. If I open this page and it has an MCQ and the right side is dynamic, the left side is not dynamic. Can you statically generate the left side? The answer could be no, but I think you can. Let me know either way. Feedback. The key to learning is feedback. Bhai sahab, public feedback. I'm just trying to decide to move forward, but sometimes it creates ambiguity. Regarding DSA polls, 60 online classes, recording of the creator. But Harkirat shows bad quality Zoom recordings at the worst. I know. I don't think I'm doing this. This is the first time I will not follow polls. And for two reasons. Number one, yes, very hard to Zoom recordings are a pain, especially if it's a recording of a live class. To understand, I don't think anyone will go through this. Exactly. I get your point. And the thing, it's not happening. The second thing is it's very expensive. It's almost 7-8 times expensive to get a cohort from someone versus just getting an instructor. And I'd rather spend that money on bounties. I think this is a web dev cohort. If we are going to burn money, rather burn it on something that helps everyone learn the thing that is the goal of the cohort. DSA is something extra. I think a small population might might help out from Soham's course, especially college student looking for C++ classes. I think that's why, but yeah, I get your idea. Rectangle is more as useful. Let's call Mac. Yeah, look at that. Cool. All right. What happened to the merchant app in the Paytm project? If you're completing it, can you please provide the guidance? Yeah. So the merchant app needs WebSockets, which is why we've done WebSockets today. Probably in an offline video I can. There are a lot of offline videos that have piled up. So let me complete them first. And 1 to 0 to 1 people can still stay, as I said, until the end of the month. So if you push a little bit more and tag me on Discord, there's a good chance I make a video on the merchant app. It'll be difficult, like it'll be like 3-4 hour video. Share some Rust resources. The Rust book, best one. Okay, so that Uh, I'm not excited. I just like this, man. It's just easier. I think it's more productive. It's more, something new you learn. Everything else is, everywhere there, which is why I'm a little excited. It's also easier, as I said, because, it's simple stuff. It's not a lot of code, but it's, when we reach Kubernetes, you will actually see this. Run 5 commands and you have something running on the cloud, things like these. So, yeah. What else? Cool. I think that's it. We'll call it here, guys. I have to meet someone, but this was great. Thank you for joining. Let's do some more pub subsystem messaging queues tomorrow. All right. See you guys. Bye bye. Jadev, try to go through the video again. Most probably it'll answer questions. Cool, guys. Bye bye.